Hello, we're going to talk about this limit. So we know sine theta over theta approaches 1 as theta approaches 0. But what about the difference between 1 and sine theta over theta? We're going to create a new variable, which is that difference, and we're going to see how it looks when it gets close to 0. We'll plot it. So we're going to plot in a range near 0, 0 to 1 degree, not including 0. So the plot looks like a parabola. So since it looks like a parabola, then we can divide by another theta squared and create a ratio. We can plot that ratio. It ought to be a constant. And it does look like a constant, and the constant turns out to be 1/6. You would have to look at the data to verify that, but it really is very close to 1/6. So this is what we want to prove. And it's actually a complicated proof to do without calculus. We'll use this identity. And I'll only outline a little bit of this proof here. We subtract 3 theta from each side and then multiply by -1. And then we divide by 27 theta cubed. And we're going to create something that looks like the limit in 3 theta on the left-hand side. And on the right-hand side, we have 1/9 of that same limit plus 4/7 times sine theta cubed over theta cubed. We can take limits, assuming those limits exist, and then evaluate the limit as 1/6. Now, the longer proof requires showing that the ratio is bounded as theta goes to 0. And the longer proof is pinned to the comments if you're curious. It's easier to prove things that you already are sure are true. And graphing and data analysis can help find these truths. That's a kind of a theme of this channel. We go from data to proof.